Good morning. I am going to introduce to you the work that has been carried out in the field of laboratories here in Spain, and that has allowed for the development of these two standards, these two Spanish standards, with regards to methodology, the methodology of the friction pendulum. So the directive caused for a change in concept and how to understand the regulation here in Spain. This allowed for the publication of a code in 2006 that included some basic requirements that are based on the essential requirements of this directive. And we find here the requirement of usefulness. Here is where Juan and myself work, and we included for the first time here in Spain, in a quantifiable manner, the requirement of slipperiness, which is something that we have been working on for some years now. It is true that other regulations previously had established the need for pavements to be treated against slip, but we didn't have a criteria quantification with regards to this risk. In Spain, for instance, the technological rule, which did not have a character of a regulation, started defining how we could quantify this limit, this safety limit, and we used at the time for ceramics the methodology of friction pendulum to somehow be able to measure this risk. As you can see, the pendulum has already been used for some time, and we have known it in our labs in Spain for quite some time. Now, in 2006, the ministry tried to include this quantification of the risk of slipperiness within the technical code. And when they did so, they studied the international standards and European standards to see what was the most appropriate test method to include this requirement. So at that time, there was only one ENSAYO standard that was not linked to any specific product, which was the standard 12,633, an experimental standard that is not linked to any product, because we saw that each different product would use a different method, assay method. So even today, we can observe that although the Construction Products Directive, when they published the documents for the interpretation of harmonized standards, established that for determining this risk, we needed to use a sole method, just one assay method, and not as it's currently happening, where there is no European consensus with regards to the method that needs to be put in place for the testing all over Europe. The last general rule for testing this risk is 16,165, which includes the friction pendulum test, the RAM test, and tribometer. And we also had a problem, which is the fact that in 2014, the standard that they referred to within the technical code regulation framework was actually eliminated. So that's another problem. And this has also been touched upon yesterday in Spain. In the framework of the technical code, we established different sorts of pavements depending on the location of the said pavement. So we ask for different conditions and different classes of pavement categories depending on the location of the said pavement. So as you can see, they are divided by dry areas, wet areas, whether they're indoors or outdoors. And nonetheless, at that time, as I told you, the only available test was that of the friction pendulum for wet surfaces. And the characterization of the risk in the indoor dry area, since we were doing a wet test, was done by establishing safe tests, but with a test that was wet, that did not correctly represent the phenomenon of slipperiness in dry pavements. That is why we carried out a very important work at the ministry level to try and somehow find a method that would characterize in a more adequate way the risk better than the pendulum with wet pavements using the same methodology. I know that in some product standards there were essays, dry essays, but it was not really a standard that was well known in laboratories. That is why a very important exercise was carried out to try and define that methodology and to establish safety limits with regards to that methodology. And at that time, we studied the two different rubbers, 95 and 96, and rubber 96 had more precision than rubber 95. Even though this was done at the beginning within a document for the interpreting of the standards, because at that time this essay could not be included in the technical code. It was impossible to include, so it was just included as a support document in order to interpret the method that was established within the code, defining this dry test, the safety limits, but in this case we consider that we would rather use rubber 95 because it was the method with which laboratories were more familiar. And the reference rule in the technical code was eliminated, so this technical committee on slipperiness, that was actually the reflection of the same committee in Europe, they decided to develop two essay methods, two essay rules for friction pendulum with dry conditions and friction pendulum in wet conditions that were based on the European standard 16,165, but developing those aspects where the standard was still not very advanced. It was more generic. For instance, the definition of the type of rubber linked to the essay method or the verification surfaces. Deriving from the experience of the different labs, we started considering the idea that the rubber for 95 had precision problems, and also the slider for the 95 had problems that were due to the precision of the test, and which was opposed to what happened with rubber 96. So that's why we decided to use the dry method, to forget about the 55 slider and use rubber 96 for the development of this standard. But we also analyzed different materials or the behavior of this rubber with different materials to analyze where the essay should be done and where it can be carried out with enough precision. We also did some works in labs to choose a verification surface. In the end, we chose standard P from Porcelanosa for the wet essay. If we were to be using that same standard, it could be also valid for the dry method, but since it is a rough surface, we abandoned it because that roughness could cause in the rubber certain deformations that could modify the essay, mainly due to the fact that the pavements that this essay was meant for are public pavements. So only in the dry essay rule we have included the pink slip or the pink laminate. And in order to finish, in 2017, we published the 2 standards, and we also included the on-site essay. One of the main advantages of this essay method is that you can do it on-site. Other methodologies can't do it for the characterization of the slipperiness of pavements, and I just wanted to tell you that in December 2019 we have included this in the technical code. So that's all I wanted to say. Thank you very much. I am going to show you a video that Juan has sent us that shows the pendulum's essay, the essay with pendulum. This is a test for pedestrian passing surfaces. This is a calibration of the pendulum for on-site tests. This is the verification of the pendulum, of the brake pads, and the different patterns. With rubber 96, this is the reference style, PTV, from Porcelanosa STDP. This is the on-site method. This is the pad verification. There's a smooth surface and we check stability. These are the previous verifications with an abrasive material. An abrasive file. This is the pattern verification. Isotropy on site. This test can be done with different conditions. It can be wet or dry, and we can also test how clean the surface is, and we have to wait at least 15 minutes before we check the temperature. This is the verification of the positioning and of the 0 point in between sites. Cleanliness and cleaning. This is for the test, how the situation it's found in, and we have to wipe it. And this is dividing the area, the total area, in 4 different portions, and we have to select the site where the test is going to take place. 5 readings are done at 0 point. We have to check the positioning of 0 point in between locations. Temperatures. On-site temperatures with different points 1 and 2. If the difference between the average values of PTV of the 4 locations were to be over 8 units, then we would have to select 4 new locations for the test to be done. These are the final verifications. If after the test the result of the pattern has varied or is not the one expected, we will have to cancel it and repeat the test with a different pad. And after checking the same, we would have, if the problem persists, then we have to inform the client and do the test once again with different equipment. The report needs to include the following: an ID number of the report, the number, title, and date when it was issued, when the rule was issued, the name and the address of the lab, the dates when the tests were done. I'm sorry, this goes way too fast. A description of the surface, the indication of the conditions of the test, the kind of pad, the mean value of the tiles, and when, I'm sorry, it just goes too fast. The serial number of the pendulum, and if there are mean uncertainties in the test, that has to be included as well. So that was it. Thank you very much. And we will now ask